Cheerio, it's Chef Jones here, about to make my most special milkshakes ever. I am going to be making my spaghetti milkshakes, my favorite of all time. So, what that entails is the ingredients are some pop or some soda, some chocolate, some coffee because I cannot go in the morning without coffee, then some pasta sauce. To pair perfectly with that pasta sauce is some amazing spaghetti noodles, and finally a perfect veggie burger. All of these ingredients are my favorite things of the entire world. Once I combine them into this blender, I'm going to have the most perfect ever milkshake because these are my favorite things ever. So putting my favorite things ever in that milkshake, how could it possibly not taste good? What I'm first going to do is just pour some water in there because we don't want our texture to be too just like mushy. So I need that extra water in there. Then I'm going to add my soda, my pop for that extra fizz. Not too much, just the perfect amount. Then I'm going to take a chunk of my chocolate and just drop it right in there. My coffee grounds go perfectly with that chocolate taste. Then my pasta sauce. It smells magnificent already. Then finally I'm going to add some of my noodles. Just going to drop that right in there. Right in there like that. I'm not going to use the whole thing because we can always add more later. And then finally I'm going to take some of my hamburger and drop that in there as well. And comes my favorite step of the whole process is blending it all together. So all I have to do is place this lid on here. And I'm going to hit the button. Turn that on and watch it blend. I can turn it up even higher. And there we have it. So now that we've got the perfect milkshake, the spaghetti milkshake, I'm just going to pour it in here and give it a nice taste. But first, would anyone like to try this wonderful spaghetti milkshake? Just raise your hand or your cup if you want to try this, and I'll come around and I'll pour it. You don't have to try it if you don't want to, okay? Here you go, here you go. Here you go, okay. All right, again, you do not have to try it, but I would like to hear your reactions. Can anybody tell me how it tastes and why it tastes that way?
Oh! Oh!
Does anybody want to say why it tastes bad?
Because Chef Jones didn't put stuff in there that tastes good together.
Wow, I've never had a comment like that on my milkshakes. Joy, do you have something to add?
I don't think you should ever put a veggie burger and coffee together. Oh!
But they're my favorite things.
It doesn't matter. They don't go together.
Has anybody else combined something that didn't really turn out that great, and why didn't it turn out that great? Jen?
You know, I know that oil and water doesn't mix well together. We learned that in science class this week.
Wow, that's interesting. Does anybody else have anything else to add? Lauren?
One time I accidentally put salt in my coffee because I thought it was sugar, and that did not go well together.
Oh, wow. Yeah, I bet not. Oh, my gosh.
This is so gross.
I have to drink it more. I don't want to drink it anymore.
I'm not drinking anymore.
Yeah, you definitely have to. I
Done.
understand. I just definitely didn't combine the right flavors together, so I'll just have to improve it later. But for now, what we're going to do is just take a moment, take 3 deep breaths, and think of something that you think does taste good. So, 1, 2, 3. Okay, so now that you have the gross spaghetti milkshake out of your head and hopefully something good in there now. We're going to open up Nearpod and continue with how this relates to math. So, what exactly are the parts of an expression? So you may have already been familiar with the terms or the words variable, coefficient, constant, but now we have these things called variable terms, constant terms, and then below variable terms we have the coefficients. So if I had this specific example and I wanted to determine my variable terms, those terms are the terms with a variable. And you just discussed with your partners and we reviewed that a variable is an unknown value. So that means that in this case our variables are x. I don't see any other variable in this specific expression other than x. So my variable terms are going to be the terms with a variable next to it. So I see that I have 14x, negative 2x. I can't stress enough that you need to make sure that you include the sign in front of the terms. So here there's a negative right in front of that 2. Here before the 14x, there's technically a positive. There's no negative sign there. Then finally I see a negative 5x. So those are my variable terms. 14x, negative 2x, and negative 5x. Then my coefficients are going to be the number next to the variable. So we determined our variable is x, so now all we have to do is take the number that is next to that x. So in our 14x, our coefficient is 14, so I'm going to write that down here as our first coefficient. Next to our negative 2x, there is a negative 2. And finally, in the last variable term, our coefficient is negative 5. Finally, the last part of our expression is going to be terms without a variable. So that just means terms that are alone, they're by themselves, there's nothing attached to them. So here, I'm going to, again, make sure that I circle the signs in front of these terms. So my first one I see is a positive 9. So I'm going to write positive 9 right here. Then I see a positive 8. And finally, I see a positive 1. Again, I found those just because those are the terms without any variables. So now that we have some ideas flowing as to what like and unlike terms are, let's go ahead and define like terms. So in an algebraic expression, terms which differ only in their coefficients are like terms. So that means that we're going to be looking for terms that look very similar and only differ in their coefficients. So that number in front of the variable, or whatever that coefficient is attached to. Everything else other than that coefficient should be the same. So if we take a look at some examples, these examples listed under like terms are all like terms because the only thing that is differing between them are those coefficients. So what I mean by that is when we take a look at the first one, 2x and 17x, the x's are the same, so they have the same variable, but the coefficients are different, which is okay because in our definition of like terms, they only differ in those coefficients. If we looked at the next two, we have 32a and negative 2a. The a's are common, and the 32 and the negative 2 are different, and that's okay. Finally, we have 1/2 AB and 4AB. The AB's are common. The coefficients are different. Again, that's okay. If we had let's say 2x and 2x, this also falls under like terms. Even though these coefficients are the same, it still falls under our definition. They may differ in coefficients, but these are still common terms because they share the same variable. Then if we look at some examples of unlike terms, we have 2x and 17a. These are not like terms because the variables are different. So we have an x here and an a here, and that does not fit our definition. We have to have common variables there. Then we have 32a and negative 2b. So again, we have different variables, and that means that we do not have like terms. Finally, if we take a look at 1/2 ab and 4, these are not like terms because one term has variables, this term has variables of ab, and the other is a constant. So this 4 is a constant term. So these are not like terms. Now that we've discussed and we practiced determining what our like terms are and what unlike terms are, we're going to use that knowledge and practice and combine like terms. So you can simplify an algebraic expression by combining like terms. This means to combine common variable terms and constant terms. So just as a reminder, from our notes that we just did in a previous slide, our variable terms are terms with a variable, and our constant terms are terms without a variable. So we're going to be looking for those two different terms in order to combine like terms. So if we were asked to simplify the following expression right here, my first step is going to be to circle my like terms. So I'm first going to circle my common variable terms. I see that I have a variable of x in a few of my terms, so I'm going to circle those first in red. So I have a 14x, a negative 2x, make sure that you get the sign in front of each term, and a negative 5x. Then I see I have constant terms, so I'm going to circle those in purple. So I have a 9, an 8, and a 1. So now that I've determined what my common variable terms are and what my constant terms are, I have to combine those like terms. So I'm going to take 14x minus 2x minus 5x, and then I'm going to add 9, 8, and 1. So I'm first going to combine the terms in red. So if I have 14x minus 2x, I know that that is 12x. And then 12x minus 5x is going to give me 7x. Finally, all I have to do is combine my constant terms. So if I have 9 plus 8, I get 17. Then I add 1 to that, and I get 18. So my final answer after simplifying this expression is 7x plus 18. If we looked at a much smaller kind of problem, for example, 4x plus 2x, here all I have are common variable terms. So both of these are like terms. All I have to do here is add the 4x and the 2x to get 6x. That's my final answer. So when we are simplifying expressions and combining like terms, we will come across expressions containing multiple variables. So in our last example that we went over together, it was only an x in that example, whereas now we have two variables involved in this expression below. We have m and n. So my first step is going to be to circle my common variable terms. So I'm going to circle the variable terms containing m in red. So I have this 9m and I have a positive 1m. Remember that there is a coefficient of 1 right there because I have a single m. And also remember to circle that sign before the term as well. Then I'm going to circle my terms containing n in blue. So I have a negative 5n and a negative 2n. Then I'm going to take those terms and combine like terms. So I have a 9m plus a 1m minus a 5n minus 2n. So here I have to just combine my 9m and my 1m to get 10m. And then combine the negative 5n minus 2n to get negative 7n. So this whole expression is my final answer. There will also be times when we're solving expressions and combining like terms where we will see expressions containing multiple variables and constants. So again, we're going to use that similar strategy of just determining what our common variable terms are and what our constant terms are. So I'm first going to circle my common variable terms that contain c, and I'm going to circle those in red. So I have a 2c and I have a negative 1c. I just like to put in that 1 to make sure that I know I'm subtracting 1 from the rest of my c terms. So then I am going to circle the terms containing d in blue. So I have a positive 3.7d and a positive 0.3d. Finally, all I see I have left are constants. So I'm going to circle those in purple. So I have a negative 2 and a positive 5. Again, as I'm circling, I'm making sure to circle that sign in front of each term as well. So I'm going to take all of my terms in red and the ones that are containing c. I'm going to rewrite them right here. So I have 2c and I have a negative 1c. Then I'm going to write the d terms. So I have a plus 3.7d plus 0.3d minus 2 plus 5. My final step is to combine all of my like terms. So I'm going to start with 2c minus 1c. It's going to just equal c. You could have a 1 here, but we all know that the coefficient of this c is 1. Then I am going to combine 3.7d plus 0.3d to get 4d. And finally, I'm going to combine my constant terms. Negative 2 plus 5 is just going to equal 3. So my final answer after simplifying this expression is c plus 4d plus 3. We know that like flavors make a really good milkshake. Unlike flavors that shouldn't be combined definitely do not make a good milkshake. Just like when we are combining like terms in math, we should not be combining unlike terms in those expressions. So now I will come around and if you want to try this new milkshake, just raise your cup and I will pour some in. You don't have to try it if you don't want to. Mr. Sperano, you want to try?
Sure.
Here you go. All right, how does it taste?
This is delicious. a great combination.